Welcome to all students to Lab Lecture 3. Lab Lecture 3 will cover data analyzing and visualization for artificial intelligence and big data course. My name is Professor Abul Qasim. The first part of the data analyzing and visualization cover NumPy. So let's dive inside the lecture. We have too many things to cover. At the beginning, what we need to cover, we'll cover introduction to data analyzing, and then we'll go to section data analyzing and visualization for AI and big data. After that, from the Python point of view, we'll see data analyzing and visualization. Through this section, data analyzing and visualization, including several key libraries, which is including the NumPy, Pandas, and Seaborn and Matplotlib. But for the first section, we will cover introduction to NumPy. There is an issue which is related to comparison between NumPy and list, which is similar together. We will discuss why the NumPy is faster than list. We'll see some reason there. Core feature of NumPy, some use cases and application of NumPy will cover. Then come to the conclusion. This is the short review for theoretical part of NumPy. Once we finish this section, we'll touch to the hands-on exercise. So now we are in the lab lecture section. Okay, introduction to NumPy. So NumPy is very famous application which is introduced around 2005 and offering very strong tools which compared to list faster, and the programmer feel much better when they would like to make 1D, 2D, or 3D matrix easily. They can make through the NumPy. So before we touch NumPy, NumPy is one part of data analyzing and visualization, part of AI and big data. So when we talk about the data, you remember in the DIKW pyramid, one section was the data. Then when we want to go one level up to the information and continue pyramid through the AI analyzing, which is a start from here, as we discussed before, we need to do some analyzing and visualization. So definition of the data analyzing refer to, inspecting, preparation, modeling, and editing, manipulating to find out useful information, because we are going to go to the information level. To support decision making, because here is the top decision making in the optimization level. So this is the data analyzing, and visualizing is the graphical modeling tools of data and information. So why the data analyzing and visualization is important? Because through that one, we can understand the pattern, we can communicate finding effectively, and then this is very important for optimization level, which is based on the data-driven, start from this part to the top. So data analyzing and visualization, what we touch in the direction of the AI and big data, which is topic of our course. So AI model rely on how much data, already structure and prepare, because most of the data, they are unstructured data. So we want to unstructured data to structured data. So in that case, data analyzing very useful, and with combination of AI. And also we need to drive wisdom from data analyzing to improve our output model. So big data, as we discussed, like 3V, remember 4V, 5V, 6V, and 9V, we discussed before about the big data. We really need, for this sort of V, we need some sort of powerful visualization and analyzing. So data visualization analyzing, they have a very close relationship with big data. Role of visualization, so this makes understanding and cognitive learning of big data and huge data be easy. And we will find, because in the pyramid, in the data part, many data here, we want to make relationship between data. After finding relationship, we will go one level up to the information. So in that case, visualization, it would be very important. So to manage data analyzing and visualization, we have some, language, developing language. The Python is a powerful, has a very rich architectures, including many powerful library for data manipulation and for demonstration of data. The key libraries of the Python, which is NumPy, Pandas, Matplotlib, and Seaborn. This 4 library we will cover theory part plus hands-on exercise. I'm doing some. We will do some practical thing. For NumPy, that is useful for numerical operation. Pandas is a tools for editing, removing, and somehow we call it manipulation, data manipulation. Matplotlib is some sort of library for make better plotting. And Seaborn give us some statistical visualization which help us to extract pattern of data, go one level up to the other parts. So, introduction to NumPy, we can consider NumPy, which is related today in this section, a fundamental package for numerical computing. It looks like multi-dimensional array, and it is fast. So we will explain why this is fast. Function for doing the mathematical operation is very useful by NumPy, and easily NumPy is good for handling the big and huge data, so which is good for big data. Many cases like handling arrays of data, matrix for linear algebra, NumPy play very important role. Simply we use import NumPy as NP. NP is the abbreviation of the NumPy. As you can see here, everything can be done. For instance, when we are using this code, that we make a 3-dimension. This is 2-dimension. This is 1-dimension. So it is used for handling multi-dimensional array, large collection of mathematics, and that is introduced, as I mentioned, 2005, successfully handling the n-dimensional array. Then optimize performance and vectorization for fast computing. There is one question. For the beginner, they are saying that NumPy is similar list. What are the difference from list and NumPy? The biggest difference that list is slow and NumPy is fast processing. Why? Because of the reason which we are going to explain. Suppose you consider one cell of the matrix, usually computer consider as a binary, and then for the NumPy you need make 32 based character and bytes. But for list, here 1 is enough, so that's why it's faster. But here you need for each one make this sort of number to register object value, object type, reference count. So that's why NumPy follows some fixed type data structure and data type that's very helpful to increase the speed. Another reason that NumPy cover better environment is a continuous memory management. For data in the memory management, when we say contiguous memory, that means continuous memory. In the list, this is not the case. in the data is distributed in memory, but NumPy make it every data clear and continuous each other. So that makes vector processing speed increase and efficient usage of the cache. So main advantages of the NumPy, we could say speed and memory efficiently. Easily multi-dimensional array support. In the list, we cannot easily multiply two lists together, but in the NumPy, it is possible. Easy integration with the other library like Pandas, TensorFlow. So this is good. So that's why we started NumPy first. So if we see here, as you see here, list, when you define by like A matrix and B matrix, if you multiply two matrix, you will get the error. But in terms of the NumPy, easily you can multiply two matrices together. So that is wonderful. So let's continue. As I mentioned that NumPy give the array creation single and multi-dimensional and mathematical operation easily, efficient through the memory management. Vectorization faster situation made for NumPy. And use case can use for scientific computation, machine learning, and data analyzing. So backbone of the data manipulation in Pandas, it is NumPy. So many real applications like weather forecasting, medical image analyzing, many big company like Netflix, Google using NumPy. So as a conclusion, why NumPy is important? Because that is fundamental. And we will do some practice to explore why NumPy is important. So I quickly finish the theoretical part and I'll go for hands-on practice, right? For hands-on practice, what we need to do, we will touch some practical exercise related NumPy. This practical exercise, it is including several sections, such as when we start the NumPy, we will start with introduction, and after introduction, we will touch another section, NumPy indexing and selection. After that, we'll reach to the NumPy operation, and finally, we'll do a NumPy exercise. I'll put some a small clip between each section. You will see I already designed very nice clip separation. You will understand which part is belong to which part. Okay, let's dive into hands-on practice. Okay, let's go Google Colab. We need to open the new project. Then you need to make introduction to NumPy based on if you need to make a bigger. So now, welcome to NumPy tutorial. In this lesson, what we are going to do, we'll cover basic of NumPy. So you, as I mentioned to you before, you can, to make it clear for every part which you are doing, it is better to make it separation by texting. We'll cover some basic which is related to the introduction part of NumPy. The most important library is a NumPy, which is deal with array manipulation in Python. Whether you are dealing with data science, machine learning, and even scientific computation, NumPy will be your go-to tool. Let's dive in. NumPy, short for, can you tell me why it is NumPy? NumPy, abbreviation of what? Just pause the video. Okay, yes, some of you right. Numerical Python. Numerical Python converted to NumPy is a powerful library that makes working with arrays and matrix much easier. It is widely used because it is faster and integrate and merge very well with other Python library, thanks to its underlying C-based operation. What I mean codes that are written in a C or C++, which is very fast language that makes NumPy to be powerful. So let's make some topic which we start importing NumPy. So what we need to do at first, as you see, I use double hash, so it's a little bit smaller. We need to do importing NumPy at the beginning. So simply import NumPy as a NP is the abbreviation of NumPy. So as I mentioned before, you may remember, if you don't do this, it is okay. But many times you need to, if you want to make an array, you need to use NumPy dot array as an object. But if you use this section as an NP, you don't need repeat NumPy. You will say NP dot array. This is the reason. So the shift key, shift enter or press this one. You can import, this library to our, coding. So this is the first part we need to import. We follow the common practice of importing NumPy, which is very important. NP here called alias. We can reference it easy through our code. So remember, this is the alias. Okay, so to make the screen bigger, you can press F11. If you press 2 times, will be written back. 1 time, go to whole screen. Pay attention that we could alias it as any other word, but it is always best to use the alias which is most famous for each library. For NumPy, this alias is NP. For pandas, its alias is PD. So this is easier to remember, by the way. So another part, which is creating, I can use italic, but I prefer at this time use not italic, whatever you like, array from. So we are going to create arrays from the list. So let's create our first NumPy array. You can convert a Python list into NumPy array using this function, which is np.array. So at the beginning, we need to write my list. Okay. You remember array 1, 2, for example, 3, and then NumPy. This is the alias dot. As you can see, here many options come. So you just use the array, right? My list. So through the n.array function, we'll create a simple one-dimensional array, which is also known as a vector. Remember, and shape is like if you run it. So one-dimensional array, which is called also vector. Let's make a two-dimensional. So let's copy paste to save time. I need to add one more bracket. For example, 4, 5, 6. Then 7, 8, 9. And here we call it not list. Let's say matrix is better name, matrix. And bring to the NumPy to create the matrix. So this 2D array known as a matrix, by converting a list of lists into a NumPy array, we can make 3 by 3. So this will become 1, 2, 3, 4, 5, 6, and 7, 8, 9. So this is easily what we can make 3 by 3 matrix. So now let's make this matrix. Let's use I make an italic under this topic. So using built-in methods to create arrays. So we are going to use built-in. So because NumPy provides several built-in functions, so easily NumPy array, NumPy arrange, not array, arrange. For instance, when we say 0 to 9, because we are using the built-in function to generate the array, they are especially useful when you need to large array or array with specific values. These most common methods, which is called arrange, generate, several space value in array. So through this arrange, we can easily make one array start from 0 by 9, 0, 1, 2, 3, because this is the number of that one. Since we have a 0, number will be printed 1, 2, 3 by 9. See? Yes. So as you can see, here I have array from 0 to 9. Remember, not including 10. So now we can also add one more number, specify the step size in arrange. For example, let's create an array of even number between 0 to 9 by setting the step size 2. So if I make a step size 2, what would be happen? Then only keep the even number. That means remove the 1, remove 3, keep 0, 2, 4, 6, 8. And because now we want to have, for example, 10 even, we can increase 11, then we can have a 10 inside the array as well. So if we do, we will see the result, yes. So let's explore how we can create array filled in, entirely with a 0. This is useful when you need to initialize array before performing operation. Here, we will create an array of 3 0. So easily we can make a, let's make NumPy zeros. So we could say start with the, when we say 3 component, that means we want to start from 0, 0 and 0. Means we initiate, make an array with a similar function. So this will be show us array 0, 0, 0. If I put np zeros, like I want to make a 2-dimensional. So 2-dimensional means x and y. When I'm saying, for example, 3, show me same thing, but 0, 0, 0, 0, 0, 0, 0, 3 by 3. So then I need to make 3 by 3. So this would be the error. Here, what we need to do, this is consider, we need to make a, one more. This error is because 0 method here, built-in method, needs one argument. When you are using like this, parenthesis 2 argument, this is error. Because when I use 2 parentheses, this considered as a 1 argument. You may remember parentheses, it was the tuple data structure, remember? So when we use 2 parentheses, consider inside this parenthesis is for 0. These 2 together with the parentheses makes 1 data set, which is tuple, remember data set before, and make 1 argument. Then in that case, it will be work. You can easily change, for example, you can put 5 to, then you can see such a result. We'll generate array filled with 1. For example, if you want to instead of 0, you can generate NP ones. Then in that case, if you need 1 dimensional, you put, for example, like 5 will be show you 1 1 1 because the built-in is a ones, right? Will be shows 1 1 1 1 until 5. So you can change it, for example, 3. It will be 3. If you want to make 2D, you should use tuple. If we really need matrix, we need to pass a tuple specifying dimension. So how? Easily we can use same, but inside we need to use tuple. Then you will see 1 1 1 is a 2D. So let's go another part, which is using the line space to create array. Remember, if you want to make a when let's finish array. So when you shift enter, sometimes you want to in the text you want to mention to the some built-in function, because when you see you cannot fill this is the built-in. So in that case you need to I want to make a code base. Not should single quote. This is wrong. Should be backticks. Backticks is the first keyword in your computer, which is close to number 1 and upper the tab key. That is called backticks. So if you shape is this is backticks. This is the single quote. So you need to use backticks. Then when you shift enter, see this will be highlighted. That is a specific code. So line space function generate evenly spaced value between 2 numbers. For instance, when you say NumPy line space, so for instance 0, 10, 50, you can increase number of these numbers. Or for instance, let's first simple one, 0, 10, let's make simple one. So unlike arrange, where you specify the step size, here you define how many value you want to between the start and end point. Okay, let's create 3 equally spaced points between 0 and 10. So between 0 and 10, so 0 to 10, 3 equal number. So when we have a 0, 1, 2, 3, 4, 5, 6, 9, 10, so what would be 3 number which is has the same space? Of course, one is the 0, one is the 10, and the middle one is the 5. So should make an array with a line space 3, beginning start from 0 to 10. So showing 0, 10, and 5, 0, 5. Let's check it. Yes. So if we want to more accurate number, for example, we need to make between 0 and 10 not 3. We need many, here we make a 0 to 10. If I say 3 part is easy, right? That is not 3. Actually, we need 3 points, not. So that means 0 to 10. So 1 point is here, 1 point here. We need middle point, right? So middle point is a 5, right? And then we can claim that we already make a 3 same space point. So 0, 5, 10. So how about between 0 to 10, we make, for example, 20. Then what would be happen? In that case, it would be many point, right? 20. Okay. Then what would be happen is between each point is more precise and very small. Means somehow we increase the accuracy. Like pixel size is more a small pixel size, you can see the high quality image. For example, if I put 20, for example here, if I put a 20, then the result you see is that from 0 to 10, very detailed space. Or if I put like 50, you see more 0 to 10, but more detailed one. Okay, let's go for another. We are going to creating identity matrix. In linear algebra, you may know that identity matrix are a special matrix with ones on the diagonal and zeros everywhere else. So NumPy can make it very easy to create identity matrix using which function? Using, let's see, with the I function. Let's generate 4 by 4 identity matrix. So in identity, we will see should be one matrix. It will be diagonal is a 1, diagonal wall. Other matrix element is 0. So you will see 4 by 4. Here is the 1. Other element is a 0. Let's check it. Yes, exactly. This is the you definitely knows in algebra. After talking about the arrays and matrix, let's dive into word of randomness. So which is very important for numerical, because NumPy is a numerical Python, right? So let's check it. Random number generation. Okay. You can press Shift Enter. Random number generation is essential in the data science, especially when we are going to use for AI. For many tasks like initializing model parameters, or for example, creating randomized dataset. Okay, let's start with the one random, let's say NP random. Let's start for here this generate random numbers between 0 and 1 from a uniform distribution. So when you go for that one, we will say, okay, generate for us 2 random number. So in that case, you will see this will be generate us this number. If we run it, you can see anytime random number would be different. So we see here how we can create random number. Similarly, we can create, some matrix of random number. If you put like, for example, 5 to 5, it will be create 2D in the 2D matrix with random number. And every time see the number, when I press, the number will be changed. So this is between 0 and 1. And this is useful when you are quickly generate random data for testing. If you want random number from a normal distribution, like Gaussian, Gaussian distribution, we can use, for Gaussian, we can use NP random instead of rand n, means the Gaussian distribution. This function retains numbers from a standard normal distribution, which is including both positive and negative value. Okay, let's generate random number from a normal distribution. For example, here, let's start with 2. So you can see that value of sometimes see including the positive and negative. Whatever, anytime I press, you can see the random number, right? So this is 1D. Of course, you can make a 2D. Random numbers. Anytime generate 1. So for random integers, we use rand int. So we can use np random rand int. This function generates random integers between a specific range. Let's create, for example, an array of 10 random integer, okay, between 1 to 100. So between 1 to 100, 10 random number. So what does it mean? You will see one matrix, element of the matrix is a 10, but the numbers between 1 and 100 would be changed. See, if I press one more, the value changed, but value not more than 100. Okay, let's another part. Array attribute and methods. Now that we know how to create arrays so far, let's explore some useful attributes and methods available in NumPy. Okay, first let's create two arrays. One using arrange and the other using random integer. So let's methods. So we are going to make arrange one array, make np arrange 25, and the other this is this is a simple array of numbers between 0 to 24. Remember, now this already assigned to here, nothing shows because assigned in the memory. Okay, next let's create a random array of integer, for example between 0 and 15. So let's make random ran array. Okay, then NumPy random, then ran int integer, so between 0 to 50, right? And let's consider 100. Okay, there is an error. Okay, should be rand d. Now is okay. So if you want to see, because already assigned in the memory, if you want to see easily, you type it, name of that, you will see the result. So this array already assigned in the memory is like that. One array start from 0 to 24, including 25 elements. So this is dimension 1 arrow and 25 column. And if you want to see this one, run array, the result, this is, you see that start from 0, and this is randomly, only integer, and number not change. If whatever you press, you will see the number change, but every number not more than 50 is a 10. Okay, we already have these two in the memory. Let's some other powerful feature of NumPy. We will play with this array and with run array from now on. Let's put some naming. I want to talk about reshaping. Reshaping when we want to reshape array, right? This is one of powerful feature of NumPy, which is ability to reshape array. When we use the, like for instance, array reshape, we can change the shape of an array without altering data. For example, let's reshape this one. This array we already create. We want to reshape this one. If we reshape this array, we want to reshape this array, for example, let's 5 to 5, because now is only one array, one column, and 25 column, one row. I want to make 5 to 5. I want to reshape it like 5 rows and 5 column. So to do so, let's make 5 to 5 and see what would be happen. Yes, when using the reshape, we need to pay attention. That is, if you multiply by 2 parameters passed in the reshape function, it must be equal to number of elements in our original array. So because original array was 25, if I put 4 and 4, that was the problem. Because 5 and 5 is 25, 4 and 4 not mix, that makes error. So notice reshape does not affect the array object at all. In fact, it only return another object created from the first object, but a different shape. So if I, for instance, if I type array, still is 1 to 25, is one column, one row, 25 column. If I press, see, the original does not affect to original array object at all. Actually, only return another object created. As you can see, we still have the same array, but if for example, I do like this, new array, then keep it after processing, assign to the another array, reshape 5 to 5, assign in some array, and then new array. See result? You will see that we already save it, and I save the object created by reshape method. This way of manipulating object is common between both NumPy and Pandas library, remember. And it is consistent with the functional programming because of immutability it provides. Okay, let's do some action like finding maximum and minimum value of the matrix we already created. Let's move on some useful methods. for working with array, like max, for example, random array, let's say max. So what was the random array? This was random array. This was, yes, random array. So max here is 42, right, in the memory. So should be shows 42. So random, okay, we need to put max m. So 42. So if I change it to run it again in the memory, it will be now is a 41 is a max. 41. So if I find index of maximum value using argmax, in that case we need to run argmax. So this argument max showing index of maximum number. For instance, 41 here, 41. What is the index? 0, 1, 2, 3, 4, 5, 6, 7, 8. Should be shows 8. Right. So in this way, we can go for, like, let's try. This is same thing for minimum. Min. If you use min is here, as you can see. Minimum is here, minimum 5. And then index is 0, 1, 2, 3, 4, 5. Index is 5. So if I use arg min, this also 5, showing the index. Okay, almost we are going to finish this part. Just 2 sections remain. Checking the shape of array. Checking the shape of an array. Every array in NumPy has a shape attribute showing the description shape, which tell us dimension of array. Okay, let's check the shape of original array. What was the original array? Remember, this is the original array. What was 1 to 25? If I do shape, show me the shape. So shape is a 25, showing that the including this is including 25. It will be shows 25. Now let's reshape it, this array, to a matrix with 1 row and 25 column, and see what new shape looks like. Let's say shape is this. So I want to do reshape, then 1 to 25, and shape. Let's. Here we try by reshape. Actually, our array is this one, is a 1D array. If we do reshape to 2D, because here showing array shape giving the dimension, saying that array is 25 means 1D. Okay, let's keep for now. Let's omit this one. Just explain one by one. When I do, this is the shape. This I reshape 1D to 2D. When I do this, saying that array making 2D. So if you see this array is different from this array, right? Maybe some of you said no, it's not different. Please pay attention in detail. If you attention, you see one bracket, here you see 2 bracket. So now is a 2D. So I can use array shape, right? Will be show me the size, showing 1 to 25, means 1 column to 25. See? when we do, because we need to assign some new array, because as I mentioned to you, reshape will be deleted if you don't assign. We need to put like here, what we did here, like we need to do like this, keep the array. To avoid that problem, to avoid not assigning to the new variable, then you bring this one here, put like this. In that case, if you run this, will be show 1 column 25. See, means reshape from 1D to 2D, and shape shows up the R dimension, 1 column 25, 1 row 25 column. If I remove this, shows the real array, and this array 2D, this array 1D. So this is the point. We already, and this is very useful. Reshaping is very useful later on, is very essential technique, especially when preparing data for machine learning method. Remember, for machine learning method, we need this one, this technique. Many times we need to use it. Okay, last part, almost I'm finishing. I believe you enjoy a lot. Checking the data type of an array. So this is the last section. As a lastly, NumPy arrays are homogeneous. What does it mean, homogeneous? Meaning all elements in array must be same type. You can check data type of elements in array using dtype attribute. Let's check the data type of our main array. So main array was, when I say dtype, so will show me this is dtype showing what data type has. Should be in integer 64, I guess. Yes. So that's all. So let's wrap up our discussion. We learned basic of creating array, generating random numbers, reshaping array, using important array and methods in NumPy, and we try to mention this is fundamental of working with data in Python. In the next section, we will explore more advanced topic like indexing, slicing, broadcasting. Okay, see you there. Thank you very much.